One of the first things you learn to do when you use a computer for the first time is to operate the mouse and type on the keyboard. At first, it goes slow, but as you become more competent, you interact with your computer and it responds as you want it to. But what does it really mean to interact with your computer? In the context of using a computer, the term interact simply means to exchange information, or even simpler, send and receive information. So essentially, a computer is sending data to you and you receive it. In turn, you also send some data to your computer and the computer receives it. I've talked about the mouse and the keyboard, but can you think of other ways in which you and your computer interact? Computers have various input and output devices. The input devices include a keyboard, mouse, microphone, camera, touch-sensitive devices, and so on. The output devices are things like speakers, monitors, headsets, and haptic devices, to name just a few. You use all these devices to send data to a computer and receive data from it. But there's something else that supports communication with your devices. These are graphical user interfaces, or GUIs, which facilitate your interactions. GUIs are popular because they require very little training to use. GUIs offer an easy way to interact with devices, but they also somewhat limit the scope of human-computer interaction. As an alternative to GUIs and input devices, such as microphones, you will learn to interact with your computer through the command line. The command line is a very powerful alternative because it allows developers to perform tasks quicker and with enough experience, less potential for errors. To use this powerful tool effectively, you need to have a certain level of knowledge. You might feel that the learning curve for the command line is a bit steep, but take it from me, the payoff is definitely worth it. By learning just a few commands, you can perform various tasks, such as creating new directories, creating new files, combining directories, copying and moving files around different directories, and searching through files using various criteria and keywords. As you become more advanced in using the command line, you will be able to perform tasks such as track software, access and control remote servers, search for files using specific criteria, unzip archives, access software manuals and display them in the command line, install, upgrade, and uninstall software, and mount and unmount computer drives or check disk space, and so on. Pretty advanced stuff, don't you think? But the list goes on. You can write scripts to automate various tasks, control user access to files and programs, stop, start, and restart programs, create aliases of only a few characters long to initiate very long commands, download files from the internet, run various software, and finally, run and control self-contained virtual software, which is also known as containerization. There are many, many ways to use the command line, but for now, I will guide you through some basic commands to get you started. First, the cd command, which stands for change directory. This is used to point our command line to a specific directory, for instance, a certain folder. For example, on Linux, if I type cd // and desktop, I will point the command line to the desktop of my computer. When you type cd ... you will move out of the current directory and back into the parent directory. Next is the touch command, which makes a new file of whatever type you specify. For example, to build a brand new file, you can run touch followed by the new file's name, for instance, example.txt. Note that the newly created file will be empty. You can also make new folders using the mkdir command. For example, mkdir followed by the title you want to give the new folder. To view a history of the most recently typed commands, you can use the history command. There are many other commands that you can use, but with the ones I just introduced, you can already do quite a lot. I'll take you through a quick scenario as an example. Let's say you want to point the command line to the desktop directory, and then add a new folder there titled My.js project. Next, you want to point the command line to the My.js project directory and make a new file which you will call example.js. And finally, you want to open the example.js file in VS Code. To do all of this, you will need to run the following commands. The first action you'll do is to use the change directory or cd command. Then you want to use the mkdir command to make the new folder. To move into the new folder directory, you use the cd command again. And then you use the touch command to create the file. The final command is the code command, which will open the file in VS Code. If you've run all these commands correctly, you'll end up with a my.js project directory on the desktop with the example.js file inside of it, and additionally, that example.js file open inside VS Code, ready to be edited. In this video, you discovered that you can interact with computers on a more advanced level through the command line. You now have a better idea of what kind of advanced tasks the command line allows you to do. And you are also ready to try out a few basic commands. I encourage you to start practicing some of these commands. Just like you got better and better at typing and moving the cursor with your mouse, I assure you that with practice, you will soon use command line like a pro. I'm pretty sure you use your phone to perform a number of activities, such as sending messages, shopping online, and watching videos. You simply tap your screen, scroll, and swipe. But have you ever thought of how your phone responds to your tapping, scrolling, and swiping? You interact with your phone and computer through a graphic user interface, or GUI, which is just a layer above underlying commands that tells the device what to do. Developers, however, need to know how to use specific commands to perform various types of tasks. For example, to create a new folder on the desktop, you right-click and choose New Folder. In the command line, you use the specific command mkdir to achieve the same result. Having a grip on Unix commands specifically is a great skill to have in today's software development world. In this video, you will get started with a few basic Unix commands. Did you know that the majority of companies run their platforms on the cloud, and 90% of these systems run on a platform called Linux? You might be wondering why I am discussing Linux while the topic of this video is Unix commands. To answer this, let's explore some history. Unix preceded Linux and was developed by Ken Thompson and Dennis Ritchie and team at AT&T Labs in 1969. Linux came much later on and was originally developed as a hobby by Linus Torvalds, hence the name Linux. The commands that you will explore in this video originated from the Unix platform, but you can use them in most modern environments that run some flavor of Linux. Using the command line could seem a little intimidating at first, but you will quickly learn that Unix commands are simply a layer below the normal actions, such as opening file directories or renaming files. Windows, for example, became the dominant desktop operating system mainly due to its easy-to-use GUI. Windows allowed non-technical users to perform tasks without having to learn a list of commands. But you, as an aspiring developer, will learn to perform tasks using Unix commands. Before I delve into some of the most common commands, it's important to note that each command has a set of helper instructions. These helpers give detailed information about how the commands can be run and how something we call flags can be passed. One of these helpers is the man command. Man is short for manual, and when called against a command, it will display a detailed manual of instructions for that given command. For example, the command man space ls will show you the detailed manual of instructions for the list command ls. You can also use something called flags in conjunction with Unix commands. Flags are used to modify the behavior of a command. Think of them as options that can either change or extend the functionality of the given command. Next, you will learn about some of the most commonly used Unix commands, and in the next video, you will see some of them in action. The cd, or change directory command, is used to move from different directories of the file system. You can learn more about working with relative and absolute paths from the additional reading at the end of this lesson. ls is used to show the contents of the current working directory. The ls command can accept many different types of flags that will change what is returned in the response. For example, ls-l lists the file out in list order and shows the read or write permissions, owners, and groups it belongs to. ls-a, on the other hand, will list all files and directories, including hidden ones. The pwd, or print working directory command, shows the full path of the current working directory. The copy, or cp command, copies files or folders from one destination to another. And the mv, move command, moves files from one directory to another. In this video, you learned about some of the most commonly used Unix commands. Next time you use your device, think about what commands run underneath the GUI to complete the tasks you are performing. Okay, so I've opened up my terminal window. Let's navigate to my home directory. I type the cd command and then a tilde, followed by the enter key. Then I use the ls-la command to return all of the files in a list, including all hidden files. Notice two files, a bashrc file and a bash profile file. For now, I want you to focus on the bashrc file first. I can use the command ls.bashrc to check this file. The bashrc file is mainly for configurations. It is essentially a script file that's executed when you first open the terminal window. What's in there will be configurations for the shell itself. For example, the types of colors that I'm using. I can also add in things around my shell history, like how much history of previous commands I want to store and so on. So any configuration options that I put in here will be executed when the terminal session begins. I press the Q key to exit the less environment. The other file is the bash profile file. So I can run the less command again, this time with .profile. This tends to be used more for environment variables. For example, I can use it for setting environment variables for my Java home directory, or my Python home directory, or whatever is needed during development. Again, I press the Q key to exit. Now I will create a simple shell script. For this example, I will use Vim, which is an editor that I can use which accepts input. So type vim, and then I create a new file by typing the testshell.sh and press the enter key. And then at the top of the file, I put in what type of file I want it to be. In this case, it's going to be a bash file. If I press the I key on my keyboard, it'll set insert mode. Then I put in a hash symbol, followed by an exclamation mark, a /, the word bin, another /, and then the word bash. This lets the operating system know that this is a bash script. The script is very simple. I want to print out some type of text onto the screen. So I use the echo command and type in what I want to print out. In this case, hello world. Press escape to get out of insert mode. Then I type :WQ! To save the file. Press enter. And if I look in the directories now, notice there's now a file named testshell.sh. The other thing to notice is that this file can't be run at the moment. In other words, it's not executable. It's just a read-write file, but I want it to be executable, which requires that I have an X being set on it. In order to do that, I have to use another command, which is called chmod. After using this command, I type in the type of permissions that I want. So I type in 755. And then I want to set the file that I want to add the permissions to, which is testshell.sh. And if I use the ls-la command again, I notice that the file has now been turned into an executable file. This means that I can now run the file from the command line. To run the file, I press /testshell.sh followed by the enter key. And now you notice the words hello world are printed out on the screen. This is how you can create simple scripts and make them executable within the bash shell. I've opened up the command line, and first I want to check what directory I'm currently in. To do that, I run the pwd command. Pwd is short for print working directory. I type pwd and press the enter key. The command returns a /, which indicates that I'm currently in the root directory. This is the top-level directory within the operating system. If I want to check the contents of the root directory, I run another command called ls, which is short for list. I type ls and press the enter key, and now notice I get a list of different names of directories within the root level. In order to get more detail of what each of the different directories represents, I can use something called a flag. Flags are used to set options to the commands you run. Use the list command with a flag called L, which means the format should be printed out in a list format. I type ls space -l, press enter, and this returns the results in a list structure. Let's focus on some items in this list. First, you need to know what's the difference between the link file, a directory, and a standard file. The link file is always represented by the L, and it's always going to be at the very start of the output. The temp directory has an arrow beside it, which points to TMP. This means temp is the same link to the actual directory TMP. The next item is the bin directory, and it's represented as a D. That means that's just the standard directory, and that you can use the change directory command to actually open the directory and check its contents. Now, let's focus on the etc directory. To change directory, use the cd command. I type cd etc to change to the etc directory and press enter. Now, I type ls to check the contents. Notice that the contents are completely different from the root. The command returns what's inside the etc directory. To verify that you're in the etc directory, run the pwd command and it confirms that you are in etc. Again, if I want to change the output, type ls-l and it returns a printed list format in list structure. Let's cover a standard file, like a text file or a configuration file. The association or the symbol for it is the hyphen. In this case, it represents the file resolve.conf. Understanding the different symbols and different name conventions is important when you're trying to find specific files. Notice that there is a root, and that these just represent the owner and the group that it's associated to. So if I want to move back from the etc directory, there are two ways to do it. One is by typing in cd ... which means that I go back up to the parent directory. Press enter, and then I type pwd. Notice I am now back in the root directory. To step back into etc, type cd etc. To confirm that I'm back there, type pwd and enter. If I want to use the other alternative, you can do an absolute path. Type in cd / and press enter. Then I type pwd and press enter. You can verify that I am back at the root again. To step through multiple directories, use the same process. Type cd etc and press enter. Check the contents of the files by typing ls and pressing enter. Let's try another directory, for example, the SSH directory. Type cd SSH and press enter. Then type ls and press enter. Again, you'll notice the different output from each one. To move back up to the previous directory, I can use the cd ... and I should now be in the etc directory. And then again, back to the root using cd ... which will take you back to the root itself. Finally, I can confirm that I am in the root by typing the pwd command and pressing enter. You have now learned how to navigate and change directories. So first, I want to check what current directory I'm in by using the pwd command and pressing the enter key. You can see that I'm in the root directory, which displays as /root. If I type in the ls-l command, notice that I have one directory in here called projects. Now, I will create a new directory called submissions. I do this by typing mkdir, which stands for make directory, and then the word submissions. This is the name of the directory I want to create, and then I hit the enter key. I then type in ls-l for list so that I can see the list structure. And now notice that a new directory called submissions has been created. I can then go into this directory using the change directory command. I do this by typing cd submissions and then press the enter key. I type the ls command and notice that there is nothing in there. If I want to add some text files or some content, I can use another command called touch. I type touchtest1.txt followed by the enter key. To add another text file, I type in touchtest2.txt followed by the Enter key again. Now I run the ls-l command and notice that the two text files are listed inside the submissions folder. After this, I want to go back to the root level directory, and I do this by typing in cd ... followed by the Enter key. And then I run the ls-l command again, and notice two directories are now listed, projects and submissions. Now I want to create another directory called archive. To do this, type mkdir followed by the word archive, and then hit the Enter key. To see all of the directories, enter the ls-l command followed by the Enter key again. Once again, notice that three directories are now listed: archive, projects, and submissions. To get back to the top view of my terminal, I can clear my screen by typing clear followed by the Enter key. After this, I type in the ls-l command, and now I can see all three directories. Okay, so let's say I want to move the submissions folder into the archive folder. This requires a different command called move, written as mv. In this example, I need to specify the directory I want to move and then where to move it to. So I type in mv submissions followed by the word archive, and then I hit the Enter key. Then I can check to see if the move happened by using the ls-l command, and now notice that the submissions directory is gone. So now I want to go to the archive directory by typing cd archive. Again, I use the ls-l command, and now notice that the submissions directory is listed inside of the archive directory. Recall that I created two text files inside the submissions directory? Well, you'll notice that they were also moved to the archive directory. So I go to the submissions directory by typing cd submissions, which changes the directory. I use the ls-l command followed by the Enter key. And now you can see the two text files are present and they were moved too. You have now learned how to make directories and files and move directories and files. Okay. So I have launched my terminal and I'm running the ls command. It informs me that I have two folders, archive and projects. Next, I can change directory into archive using the cd command and search inside using ls. This reveals a submissions folder. I can then type the cd submissions command to enter into the submissions folder and check what's inside. The ls command reveals two files, file1.txt and file2.txt. Each of these files have some content in them. I can check the content of a file by running another command called cat. I run the command cat file1.txt. This returns the contents of the file, which is some simple text. Another command is the word count command, which is abbreviated as wc. To use this command, I can just call it against the file by typing wc file1.txt-w. The W flag tells the wc command to return the word count. The output informs me that there are 181 words in the file. Let's run another example with pipes. Pipes allow you to pass the output from one command as the input to another. I can perform an ls command on the current directory. Note that this outputs two file names. Let's type the ls command again. Then I pass in my pipe using the vertical line character. Then I use the wc command with the -w flag. Notice that it returns a result of 2 because there's two files in the system. So, what if I want to find the word count of a file using pipes? I just change the ls command to cat file1.txt pipe wc-w. This returns a word count of 181 for file1.txt. Did you know that you can also combine this command against the directory or multiple files? For example, I can use the command to get a combined word count for file 1 and file 2. To get this data, I just input the command cat file1.txt and then also pass in file2.txt. Then I use a pipe followed by a WC-W. This returns a total word count of 362 for the two files. In this video, you will learn about redirection and the different types of redirection you can use. The basic workflow of any Linux command is that it takes an input and gives an output. The standard input device is the keyboard. The standard output device is the screen. With redirection, you can change the standard input and/or output. There are three types of I/O or input-output redirections: standard input, standard output, and standard error. The shell keeps a reference of standard input, output, and error by a numbering system. The 0 is for standard input, 1 is for standard output, and 2 is for standard error. Now you will learn about each of these redirection types. Let's start with standard input. Taking input normally refers to a user typing information from the keyboard. We use the less than sign for user input. The cat command can be used to record user input and save it to a file. How do we take input and store it in a file such as a .txt file? Let me explain how you can do this by using an example to store user input to a text file. So I have just launched my terminal, but how do we take input and store it in a file such as a .txt file? One of the commands you learn to use frequently in this course is the cat command. This command is actually set up to take in input. On my terminal, I type the cat command followed by a greater than sign, and then follow it by the name of the input file. In this scenario, input.txt. Press enter. Now I can add text to the text file created. At the end of the text, press enter. Next, press Ctrl-D to tell the cat command that's the end of the file. To output the contents of the file, enter cat followed by a less than sign, followed by input.txt. Press enter. Notice that the text that I added from the keyboard displays. Let's discuss standard output now. A lot of the commands we have already used, for example ls, send their output to a special file called the standard output. Output direction is handled with a greater than sign. I/O allows us to use redirection to control where the output goes. Now I will demonstrate how you can send output to a text file. Everything in Unix, Linux is a file. This means every time you run a command like ls and press enter, it sends the output of the file to an stdout file. In Linux, if you want to control where the output goes, you can use a redirection. How do we do that? Enter the ls command, enter -L to print it as a list. Instead of pressing enter, add a greater than sign redirection. Now we have to tell it where we want the data to go. In this scenario, I choose an output.txt file. The output.txt file has not been created yet, but it will be created based on the command I've set here with a redirection flag. Press enter, type ls, then press enter again to display the directory. The output file displays. To view the content of that file, use the last command followed by output.txt and press enter. The content that displays using the ls-l directory includes the different files available. Errors occur when things go wrong. When using redirection, you also have to specify that the error should be written to a file. You can do that by explicitly setting the number 2 before the output arrow. And you can also combine it with the standard output of 2 greater than %1 to print both the standard output and error if any occurs. You have already learned that input is represented by 0 according to the shell. Output is represented by 1. The input stream uses the less than sign. The output stream uses the greater than sign. And the error stream uses 2 followed by the greater than sign. It may happen that an error occurs when you are outputting data to a text file. Remember that the error will not correspond with the output stream. It will change to use the error stream, which is represented by 2. Let me now demonstrate how this works. So I've the terminal open and I'm running a similar example to the standard output. Type the ls command. Follow this by -l to try and print it as a list. Instead of using a directory that we know exists, I'm going to use one that doesn't exist. Enter /bin/usr. Now type a greater than sign followed by the name of the output file. In this scenario, type error.txt. Press enter. Notice that the message cannot access. It states that there is no such file or directory. Normally, you think that it would still print the contents of the file, but because an error occurred, it prints it to the console. There are two ways to send the contents to the error.txt file. I type ls-l/bin/usr, then add the number 2, which represents the error output, followed by the greater than sign. Now enter the name of the output file, error.txt. Press enter. To see what we have inside the error file, type less followed by the file name. In this case, error.txt. Press enter. The error message ls cannot access /bin/ no such file or directory displays. If you want to handle both cases where it may find data or may not find data, you can pass in a different redirection, so it handles each one both for output and for error. To do this, again, enter ls-l/bin/usr. Next, add the greater than sign for output, followed by the file name, error_output.txt. This time, we're going to use another redirection to signify that we also want to get errors. To do this, I enter a 2 followed by a greater than sign. This is followed by an ampersand sign and the number 1 to get the output that is available. Press enter. To have a look inside the error file, type /error_output.txt and press enter. Notice that the errors contained inside the error.output file displays. And that brings us to the end of this video. Now you know what redirection is and how to use the 3 types of input-output redirections. Well done. grep stands for Global Regular Expression Print, and it's used for searching across files and folders as well as the contents of files. On my local machine, I enter the command ls-l and see that there's a file called names.txt. If I access that file using the less command, it displays a list of first names in non-sequential order, as in not arranged alphabetically. So what I'll do first is use grep to find some patterns of names that start with similar matches. Then I'll also show how grep can be passed with different flags to get different results. First, I'll perform a standard search using grep. So what I'm going to do is look for names that begin with Sam by entering the command grep samnames.txt. This then returns a list of names that begin with Sam. Keep in mind that grep is case sensitive, which means if I run the same query with a lowercase s, it returns a completely different set of results. Because this query doesn't match the capital S, it returns partial matches in which Sam appears in the middle or end of a name rather than the beginning. Fortunately, I can pass in a flag to ignore case sensitivity. I can do this with the command grep-i, followed by the keyword Sam, and then the file name names.txt again. This time, I get back both users that begin with Sam and also with Sam as a partial match in the middle or the end of the name. So the result set changes based on the type of query that I passed through with different flags. We could also do an exact match by passing in a different flag, and that's the -w, which means it'll match exactly what I'm looking for. So I'll input grep-w and then pass in the keyword Sam with a capital S, and finally our file name, names.txt. In this case, we only get back a single result with the name Sam, as any partial matches are ignored. Lastly, I can use a pipe command to combine different searches for grep itself. For example, let's say I want to search across a list of directories for certain executable files. I can combine that with different commands and search across the file structure to find exactly what I'm looking for. If I check all the executable files inside the bin directory by running ls/bin, it returns a long list of results. In order to filter that down, I can run the same query of ls/bin, but this time I'm going to pipe it. Pass in a grep and then enter the keyword zip. You'll find that in this case, I get a much smaller subset back in the results. And if I need to refine it further, then I can also apply the different flags to look for an exact match, a partial match, or ignore case sensitivity. Great work! You've reached the end of this module on the command line. It's now time to review what you've learned during these lessons. In this module, you learned how to use the command line to execute commands in Linux. You were introduced to some of the most commonly used commands that traverse, create, rename, and delete files on your hard drive. You learned how to use piping and redirection to create powerful workflows that automate your work. Having completed this module, you should be able to describe what the command line is and how it is used, explore your hard drive using the command line, create, rename, and delete files and folders on your hard drive using Unix commands, and use pipes and redirection. This module began with a video exploring the answer to the question, what are Unix commands? You learned how to determine the current working directory using the pwd command. You also explored how to create and change directories and files using the command line. You can now create a working directory, create two different directories, dir1 and dir2. Create files and directories inside dir1 and dir2. You can now also use grep to search for files, folders, and contents of files. You're now familiar with the command line. Well done! You're making good progress on your learning journey.